Welcome, everybody. Thank you for joining me on what is for me an early Tuesday morning to hear about the Analog Discovery Pro. I'll wait for a few more people to join before I get started. Looks like we have some people joining. So before I get started, I'll start with some administrative type things. I'll save some time at the end, actually a good bit of time for questions. So if you have any questions, you can put them at any time in the Q&A part of the Q&A little view, not the chat, but the Q&A. Put your questions there. I have two people with me, two assistants with me who will help, actually engineers, who will help answer some questions as they can, and then mark questions for me to answer at the end. So at any point in the webinar when you have a question, just feel free to drop those in the question and answer box, and we'll get those answered at the end. So yeah, again, thank you for joining me on what is for me a early Tuesday morning. Today we're here to talk about the new Analog Discovery Pro, specifically the ADP3450, which is the first in what will eventually become the Analog Discovery Pro line, and what we like to call perfect coworker. It'll help get your work done, but won't send you a bunch of emails about it. A joke, it actually could, and we'll get to that later. So this is the Analog Discovery Pro. And I actually recognize a few of the people that have joined and know that some of you are familiar with the Analog Discovery too. So thanks for coming back. So what is the Analog Discovery Pro? Like the Analog Discovery 2, it at its base is a mixed signal oscilloscope designed to get all of the test and measurement equipment that you might need in one device. And like the Analog Discovery 2, it is a true mixed signal oscilloscope. So it has dedicated analog and digital channels. In the case of the ADP3450, you can see there the analog channels are on individual B and C connectors, and then the digital channels are in the MT connectors, just like the Analog Discovery. So you have both analog and digital signals, and they're broken out into dedicated channels, so you don't have to sacrifice an analog channel to access digital or digital channels to access analog. You have them all dedicated. And like the Analog Discovery, there's both digital inputs and outputs and analog inputs and outputs. Along that theme of never having to sacrifice one channel for another, on the back of the device, there's also two external triggers, which can be set as inputs or outputs, so that, like many people have done, very brilliant use of the Analog Discovery 2 triggers is to link multiple of them together to get even more channels, or trigger based on some other external condition. You still have those external triggers, but they're on B and Cs now. And another, I think, important thing about the Analog Discovery Pro, it's, like I said, taking what we love about the Analog Discovery, but bringing it up to more of what a professional engineer would need. So it's still, should have had a size comparison on here. It's still portable, because portable we love, it's what we do, but it's a little bit bigger, smaller than a laptop, bigger than the Analog Discovery. In total, like I mentioned, you have separate channels for your analog inputs and outputs and your digital inputs and outputs. So you could say there's 24 digital I/O in total with 4 analog inputs. So you get a 4-channel oscilloscope, 2 analog outputs, 16 digital inputs and outputs, 2 triggers, and then there are some digital power supplies that we'll talk about later in the connector. So 4 oscilloscope channels, 2 waveform generators, 16 digital I/O, and 2 triggers on the back. Similar to the Analog Discovery, with the Analog Discovery Pro, all of those inputs and outputs can be used in the 12 different instruments that are in waveforms, ranging from an oscilloscope, waveform generator, to the digital instruments like the logic analyzer, pattern generator, some of the newer instruments like the impedance analyzer, all instruments that range from taking simple measurements to analyzing them to combining the various inputs and outputs to analyze more complex parts of your system, like in the frequency domain, or for example, the impedance analyzer if you need to characterize the impedance of a design. And I put on here and counting because in the next release of waveforms, we're going to be adding another instrument, which is, I like to think one of the huge advantages to anything analog discovery that we do is that we continue to release new instruments and new functionality in the software, which is free, and the updates are always free. So now some of the differences, what makes this an Analog Discovery Pro versus an Analog Discovery? We took what we all love about the Analog Discovery 2 and amped up the features based on the years of customer feedback that we've been getting to make sure that it's fit for any professional use case that you might have, especially with the current world, everyone working from home. So the first thing, which is kept the same and enhanced, is that the analog inputs, or the oscilloscope, is high resolution. Here you can see a screenshot of a measurement. This is the hysteresis view, and it's showing 14 bits, which is the hardware resolution, but it also has 16 bits of usable resolution with software enhancement. So you can make sure that you're getting the best information from all the measurements that you're taking on the oscilloscope. In addition to that, in order to make sure that those measurements are useful data, we've added some more noise reduction focus features. So like always, you can uncheck the noise in waveforms to get rid of what waveforms detects as noise, but we've also added a hardware bandwidth filter. So if you know that you don't need anything above 20 megahertz, you can enable that hardware bandwidth filter. And that's something that we've seen commonly people want, that you can find in some benchtop oscilloscopes. Sometimes you can't, but we've added that in the Analog Discovery Pro. The next thing is a huge addition. It's something that we get tons and tons of feedback, is that you need to take more samples, you need to get more data, longer buffer sizes. So the Analog Discovery Pro adds a bunch of external memory, which is used for two things. One of those things I will talk about later. The other one is to increase the buffer size. So for example, here is in the oscilloscope, it has up to 128 million samples of buffer. The next thing that's a big improvement is oversampling mode. So this is something that we added recently in waveforms, and it's something that in the Analog Discovery Pro can be used to significantly increase the speed of signals that you can view. So here in this first screenshot on the left, the Analog Discovery Pro introduces the ability to change the device frequency. So in some cases, 100 megahertz is better. For example, if you're trying to get specific frequencies on, for example, the logic analyzer, you want a 50 megasample per second signal, then you'd want to use 100. But if you're trying to maximize the speed of the signals that you can get, it can go up to 125 for the system frequency. And then here, oops, in this second screenshot, you can see it also, you can change in each instrument what the frequency is, if you need it to be lower, higher, etc. And then if you take that frequency and use oversampling mode, which allows you to have the device oversample and average those samples on repetitive signals, you can get up to 1/2 of a gigasample of sampling rate on the oscilloscope. And this is just the start of, as I mentioned in the beginning, this is the first Analog Discovery Pro, and this is just where we're starting. So we're really excited about the future. So in addition to adding all of those benchtop quality features that you would expect on a benchtop oscilloscope or other benchtop instrument, we also wanted to take advantage of and keep what makes a USB connected instrument so great, which is the ability to take the power of your PC and apply it to your measurements to do signal analysis, triggering, all those other things. So in addition to those features, you also take the configurability that's based on having a USB or PC controlled instrument. So the first thing, which is one of the most important things, is the advanced triggering features. And you can see here in waveforms on the left, there's a ton of features built in. So you can trigger based on an external signal, as I showed before, from the 2 external triggers on the back. You can trigger based on other instruments. So the 12 instruments, they can trigger off of each other. You can trigger off of a pattern or a logic signal that's detected. So on the right, you can see, you can have the logic analyzer decode a signal and trigger based on a value that the logic analyzer is seeing and analyzing. So cross-triggering, triggering based on patterns, external triggering. There's also a manual trigger if you need that. The next piece of configurability is on the digital side. So the advanced triggering features are in both the analog and digital instruments, and you can cross-trigger together as you might need for a complicated mixed signal system that you might be testing. The configurable I/O, this is all of the digital I/O, the 16 digital channels. You can set the digital voltage, the logic level and the threshold, and you can set the pull up or pull down on each digital channel as well, so that it's compatible and can analyze a whole wide variety of digital systems. And this is something that I'm not sure if anyone's familiar with the digital discovery, but that takes the customizability of the digital discovery and puts that on the Analog Discovery Pro. The next bit of configurability is all of the scripting that you have available in waveforms. So in addition to waveforms being the user interface for all of the instruments where you can just open it up, get started and take measurements, you can also do a variety of different scripting. There's a bunch of interfaces in there for things that you might encounter that aren't built in. For example, here is in the SPI protocol analyzer, where you can communicate via SPI to whatever sensor you might be testing or controller you might be building. In addition to the built-in settings, you can also custom script a SPI interpreter if you need that. And in all of these scripting interfaces, there's a ton of examples to help get you started. And these are based on JavaScript. Another example of a scripting interface, this is in the logic analyzer. If you're not trying to communicate out with a protocol and you just need to interpret, you can use the logic analyzer. And there's a ton of interpreters already in there. We're constantly adding more based on feedback. But if there's one that isn't there, or you need to slightly modify one that exists, you can do that as well with a custom interpreter. Next, if you need complete customizability of the instruments, or you want to link the instruments together to do an automated test or trigger one based on a more complicated signal, or have waveforms output a pass or fail condition, you can use the script editor tool that's in the waveforms user interface. And this allows you to write a large variety of scripts using all of the different instruments together. And this also has a bunch of examples in it. So there's fun examples like you can use the waveform generator to play songs. You can, with your computer, you can do other more complicated examples using the digital analyzers to trigger some scope capture to happen, calculate based on that. One of the other good examples we have of the script editor, it's not in here, but on the Resource Center, is taking a microphone sensor and looking at both the analog and digital data and calculating what you should see based on the digital signals to make sure that that digital to analog converter is working correctly. And the last and most customizable option is that if you need to, for some reason, write a custom application entirely, or you want to do a test that does not require the interface and waveforms, you can use the software development kit, which provides 5 different languages, including Python and C and others, for writing custom applications. And we have a bunch of examples when you download waveforms. They're in that file directory. There's a bunch of examples to get you started, and some documentation on the Resource Center on all of the functions. And this is all, again, configurability that's in addition to the waveforms user interface, which you can just get started, and has all the features you would expect in any of the different instruments that are included. So this is another neat example of the software development kit that is actually done on the Analog Discovery Pro, the ADP3450. And this is using some of the other features, which I'll talk more about later, to have a deployable noise pollution station. And it's using the Waveforms SDK, writing a script and running it on the device itself to take the data from a sensor, analyze that data, and then post it to the ThinkSpeak cloud. So another difference between this and other USB instruments is something I'll talk about later, which is the on-device operating system. So if you want to run a application or test on the device itself, you can do that, which is what this is doing. So a nice segue, I mentioned this in the last example. The Analog Discovery Pro is introducing something entirely new to us. In addition to operating as you would expect a USB instrument to operate, where you can use the user interface installed on your computer and communicate with it that way, take measurements that way. There's also a mode which we call Linux mode, which allows you to run an embedded operating system on the device itself, which this enables a bunch of things, one of them being standalone operation. So you could write a test on it and run the test, check on it later. And this is all using a terminal distribution of Linux. So this is an example of another custom test that we wrote, where you're communicating with a sensor and running the test on the device itself and viewing the results over the serial terminal. And one of the things that was really important for us when we introduced this new functionality, which, you know, it enables a whole new world of tests and custom applications when you can run them on the device itself, when you have the power of an operating system combined with Waveforms SDK. One thing that was really important to us was to focus the way we design this on stability and ease of use. So I put, just as an example, this is how you change between the different modes. So if you want to boot into Linux mode, you just open Waveforms and open the boot modes and reboot the device from there. And then same when you change back into standard mode, which is what we call the mode where you connect over USB or Ethernet to the user interface on your computer. You can just switch back and forth that easily. And this also means too that, you know, with Linux, you can do a lot of custom things. If you get a little too creative, you can always boot back into the standard mode, for continuing to take measurements. And then there's the recovery modes if, you know, if the creativity goes off the rails. Other things that are unique to the Analog Discovery Pro, specifically the ADP3450, is that this device introduces remote operation by way of the Ethernet port and the USB ports, which are enabled in Linux mode. So whether you're using it as an instrument connected to your PC in standard mode or with the on-device operating system in Linux mode, you can access the Ethernet port either to stream data to your computer or to stream data to the internet. And then if you're in Linux mode enables the 4 USB ports that you see here on the back of the device. And we've selected a few Wi-Fi dongles that are already like automatically enabled to be used, so that you can connect to the internet via Wi-Fi if you want to do that as well on the Linux mode. And there's some other things you can do with those USB ports. Works similar to if you have another Linux system with USB ports, you could connect a mass storage device to log data to, if you wrote a script to do that with Waveforms SDK, a whole variety of things. So remote operation, on-device operating system, 2 huge new things that enable a whole new world of customizability. And you'll notice, I should mention, on the back of the device also, there is a power jack. So with all the enhanced features, the Analog Discovery Pro connects with auxiliary power. And then for data, you can either communicate via Ethernet, USB, or if you have a Wi-Fi dongle, you can connect via Wi-Fi in Linux mode. So that was my introduction to the Analog Discovery Pro. It was a lot of information. So I saw that there are some questions, some got answered. Feel free to put more questions in either now or as I'm answering them if you have them. We'll also be posting this video of this webinar, and you can ask questions on there when we post it, or always reach out to us via social media, forums, etc. So now we can answer questions. Andrew, do we have some questions to answer?
We do. Anonymous is asking, can the logic analyzer be configured to only capture changes, and which allows much longer traces?
That's a good question. So in the logic analyzer, you can trigger acquisitions based on a bunch of different signals, including changes to what the protocol is being analyzed, or based on specific packets of data. And if there's anything that's not in that, like the specific built-in interface, you can most likely do it with scripting. There's a bunch of options for that, so that you can trigger based on something and end the acquisition based on something else. And then the buffer size increases that I mentioned with the oscilloscope, that also applies to the logic analyzer. So you can take much longer acquisitions there as well. So hopefully I answered that question. Do we have another question?
We do. Marcus Nichols is asking, is it by some means possible to use 5V logic?
So similar to the Analog Discovery and Digital Discovery, the logic analyzer is 5-volt tolerant. So you can analyze and decode 5-volt logic signals. The threshold will be the same as with 3.3-volt logic. And then we've had some customers have some success outputting, since the threshold will be similar, but officially it's 1.2 to 3.3 volts and then 5-volt tolerant. Is there another question? Any other questions?
Yes. Can you speak to any of the new instruments that are going to be added in waveforms?
Yeah, so recently, in the last couple of updates, we've added the most recent public thing that we've added was the impedance analyzer, um, which allows you to do complex impedance analysis of whatever system you might be testing. And we've seen a bunch of really cool applications with that. For example, there's a school that does a lab using a long BNC cable to simulate transmission line characteristics using the impedance analyzer. That's pretty cool. And then there's a bunch of other things you can do it to, testing your system to make sure it has the impedance that you might expect over a variety of frequencies. So that's the most recently publicly released one. And then right now it's in testing, but will be added soon, is a current voltage characteristic curve instrument. So right now we have an example where if you want to look at the characteristic curves of some device, you can use a script to configure the XY plots to it, but soon we'll be adding an instrument so you can just do it. And then that'll be available for any of the waveforms devices that have analog channels. And then when we release that, we'll also be releasing an adapter for analog discovery that makes it a little simpler to do, although you could do it with Analog Discovery Pro as well in that instrument. I see there is a clarification on the logic analyzer question I answered. So Anonymous asked, what I mean is that if you're capturing at 100 megahertz and have 66 megabytes, you still get less than a second of data, whereas if you use compression, you can sample for minutes or hours. In the logic analyzer, there's options to enable and configure compression of the data so that you can take those longer traces. Do we have other questions?
Anonymous is also asking, what is the sample rate of the oscilloscope for non-repetitive signals?
So the maximum sample rate for non-repetitive signals would be 125 megasamples per second. And then the bandwidth being 55 plus megahertz. Is there any other questions?
Not now.
Not now. All right. Well, as I mentioned, you can feel free to ask questions either once we post the video or contact us via social media, on the forum, etc. I have here on this last slide a link to the page, so you can sign up to be notified when we have stock on the page there, and then you can also access the forum from there. The documentation is all under works but up, so you can check out the documentation for more information from there. And yeah, feel free to ask us questions. Thank you again for joining us on this, what is for me a Tuesday morning. I appreciate you all taking your time to hear about the ADP3450, the first of our Analog Discovery Pro line.